Welcome to Coach Taylor's Class Notes, and today we're talking about rotations. So a rotation, pen's not working, give me 2 seconds. A rotation around a fixed point called the point of rotation. Again, mathematicians are great at naming things. So the figure rotates at a specific angle and direction. Though figures can rotate around any fixed points, the most common center of rotation is the origin. And it also just makes life a whole lot easier for us. So here are the 3 rules that we follow when we rotate shapes about the origin. So first thing I need us to understand is these 2 phrases, counterclockwise and clockwise. So counterclockwise is when we go to the left, whereas clockwise we go to the right. So think about it as if you're reading an old school analog clock. If you were to follow the minute hand, that's clockwise. If you were to go backwards in time, that would be counterclockwise. So these 2 phrases, 90 degrees counterclockwise and 270 clockwise, mean the same degree of rotation. So 90 counter is the exact same thing as 270 clockwise. So if we go and we look at this picture here, so if we were to go to the left or go backwards in time, we would be rotating 90 degrees. Whereas if we were to go forwards in time, we would be rotating 270 degrees. So that's the 90 counter and the 270 clockwise. So our rule for these 2 rotations is x comma y, because remember that's your pre-image point. The arrow denotes that a transformation happened, and then our rule is negative y comma x. All right, 180. 180 is really simple because no matter what direction you go, 180 gets you in the exact same place. So this one only has 1 degree rule, not 2. And so again, our pre-image point, x comma y, is transformed. And if it's transformed by rotating it 180 degrees, our rule is negative x comma negative y. All right, our last rule is 270 counterclockwise. Again, counterclockwise is going left or going backwards in time. 90 clockwise would be going forward in time or going to the right. So again, if this is our original image, that our long ways is 270 counter clockwise, whereas this right here, I did it backwards, sorry guys. Whereas this right here would be 90 degrees clockwise. And so our rule for this is if our pre-image point is x comma y, and then we transform it with one of these 2 rotations, is going to be y comma negative x. All right, so let's see what this looks like. So our rule for 180 degrees is negative x comma negative y. Oh, that looks like a 4. It's one of these days where I just can't write. And so we need to graph our original triangle or our pre-image triangle. So this is x, y, z. And we're wanting to transform at 180 degrees. And again, 180 is counter or clockwise, puts us in the same location. So I need to flip or make my x and y vertices negative. So we end up with a -3 and a negative becomes positive. I end up with a -6, -1. And then for z, I end up with a -5 and a +7. So let's go ahead and graph these coordinates real quick. So we have x, we have y, and we have z. So if we were to follow x, that's 180. If we were to follow y, that's 180. And if we follow z, that's 180 degrees. All right, so these next two, we are going to use the same rule. So 90 degrees counterclockwise, our rule is negative y comma x. And we know that 90 degrees counterclockwise is the same thing as 270 clockwise. And then same thing with 270 clockwise is the same thing as 90 degrees counterclockwise. And our rule is still negative y comma x. So let's graph our original shapes. So we have A, B, and C. Sorry, I'm just realizing I did not put my pre-image or my image or my prime notation on the previous problem, so I had to go fix that real quick. So let's figure out where these 3 points would go. So I need to flip my x and y coordinates and add a negative to my y. So I'm going to end up with a negative 7, comma 2 for A. B is going to end up with a negative 5, comma 6. And C is going to equal negative 4, comma 1. So we have A prime, B prime, C prime. Again, if we were to follow A's rotating 90 counterclockwise. Nope, I wrote those backwards. This one should be B, this one should be C. B is going there counterclockwise, and then C goes there counterclockwise. So they're each just taking a quarter turn about the origin. All right, so now let's graph our rhombus. So if we connect these all together, that should be G, H, I, and J. And again, 270 clockwise is the same thing as a 90 counter. So we're going to flip the coordinates. So 2 is going to go first. It's going to become a negative 2, and then I keep the negative on the 7. Then for H, I'm going to get negative 6, comma negative 5. I'm going to get negative 8, comma negative 1. And then J is going to become negative 4, comma negative 3. So that's G prime. That's I prime. That's H prime, and then J. J prime. So if we connect our dots, so again, J's 90, G's 90, H is 90, and then finally I is 90. All right, we've got our last rule, which again, 270 counterclockwise is the same thing as 90 clockwise. And we write this rule as y, comma, negative x. And 90 clockwise is the same thing as 270 degrees counter clockwise, and our rule is still y, comma, negative x. So I'm going to go ahead and write the vertices of my prime figure first. So I need to flip the x and the y. So the y is going to go first. I need to add a negative to the x, but since on G my x is 0, it just stays 0. So -6, comma, -7 for H, and then -8, comma, -3 for I. I'm going to do the same thing for these right quick. So we flip the x and the y, so the y goes first, and then we make the x negative. 8, -3, and then 1, comma, -8. And so let's graph them just to verify. So this should be G, H, and I. Yes, okay, just making sure I got prime on all of those figures right there. So if I graph these, -2, 0, -8, -3, so that's G prime, that's I prime, and then -6, -7, which is H prime. Again, it's 90 clockwise or 270 counterclockwise. Nope, sorry, I is all the way there, and then H is there. So L, M, N. Then I've got 8, -3, -1, and 1, -8. So L, M, N. Again, N is 90, M is 90, L is 90. I forgot the prime on those 3 points. Got the prime on the other ones. So that is how we do rotations about the origin.